All right, this is Robert.
I'm Savannah Martinez.
And I'm Peter Johnson.
And we are doing Lab 1. We're doing Lab 1 on Introduction to
Spectrometry.
Spectrometry. And spectrometry is a technique used to determine the structure of a compound. Most techniques are non-destructive, and the types of spectrometry are IR, which is measures the bond vibration frequency in the molecule and used to determine the functional group, and the mass spec, and it measures the fragments of the molecule and measures their mass, and the MS can even give the molecular weight of the compound and function group. Then you have the NMR, and which is analyzes the environment of the hydrogens in a compound, and which is also used for its clues as the alkyne group and also the functional group present.
Oh, okay. So what we're going to do now is we're going to look at this graph and we're going to kind of tell what we can from it. So the question here is, how many groups of equivalent hydrogens are there? There are 3. As you'll see, there are 3. 1, 2, 3. And what does this say? What information does the signal give to us about the peaks? The higher the peak, the more hydrogen it has. So this has the most hydrogen, this has the second most hydrogen, this has the third most hydrogen. And here's Peter.
Also, it'll tell you how many hydrogens are adjacent to it, depending on the number of peaks, if you can read the peaks, because you can't read them all. When we go to name this compound, they give us a molecular formula of C4H7, oxygen and chlorine. So by deducing from here, you only have 3 of them that have hydrogens on, because the rest of them don't have hydrogens. So your structure, you're going to have a 4-carbon chain with an OH group off of one of them, a chlorine group off of the other. The 2 on the end are going to be your methyl groups with 3 hydrogens. So you got 3, 6, and then your other H on your alcohol. So you got an OH group there. Now we have double bonded 2 carbons to complete the 4-carbon chain because we didn't have any hydrogens. Couldn't put a hydrogen here, so it has to be a double bond between those 2. And that's the structure of it. The different distances between the peaks has to do with their electronegativity. Like these 2 methyl groups, one of them is closer to a carbon with a chlorine, the other one's closer to carbon with an oxygen group, so that would change the distance downfield on the spectrometry. And then the third one, of course, the OH group, which have its own range where it would sit. And essentially that is the
Bulk of it.
yeah. Okay, wait, time out. It says there are 4 carbons. Do all 4 carbons have hydrogens? Of course, I already answered that, but I'm going to address it. Is 3 of them here. That means that there are only 3 with hydrogens on them. And in this compound, because of an OH group, there's only 2 carbons that actually have hydrogens on them. So that's that right there.
Yay!
Yay. Thank you.
Bye.
Bye. Yay.